All right, pre-cal students, we're looking at lesson 513, help for the logarithmically challenged. Okay, so this is just kind of review, nothing new here, it's just review of what we've been doing the last few days. To solve equations, we're solving equations here. Solving equations involving logarithmic or exponential expressions. Rewrite the equation with one term on each side. Use an inverse function on both sides of the equation to undo the log or exponential function, and then solve the resulting equation. Okay? All right, so let's see what we can do with this. We've got 6 examples. That's it. Should be easy. First one, I've got log base a of x equals 2 log base a3 plus log base a5. So first step, I need to get just one term on each side, and I can use my properties of logarithms here to simplify this a bit. So I'm going to condense this down. I'm going to bring my 2 up on the 3. So log base a of x is equal to log base a of 3 squared. And then I can, since I have a log plus log, I can bring those together as a single log with multiplication. I'm going to change that 3 squared to 9 times 5 here. And now I've got log base a of x equals log base a of 9 times 5. And so x equals 9 times 5. And so x is 45, and that answer looks pretty good because it's a positive argument, and so I'm good with that. Okay? Number 2. Log base 3 of x plus 2 plus log base 3 of 9 equals 3. So this one, always when I have a log without any variable in it, I always think, well, can I simplify that? And this one I can, right? Because I could write this log base 3 of x plus 2. I could write this as log base 3 of 3 squared. So that whole thing is just going to become 2. Log base 3 of x plus 2 equals 3. That's by property 1 or 2, whichever one says I can do that. I'm going to subtract the 2 from both sides. So log base 3 of x plus 2 equals 1. Now I'm going to exponentiate it. My inverse of logarithm is exponents. So log base 3 of x plus 2 equals 3 to the first power. The left side simply becomes x plus 2. 3 to the first is 3. X equals 1. And there we go. We are done. Number 3. 0.3 to the 1 plus x equals 1.7 to the 2 minus x. So this time I've already got one term on each side. I'm going to do natural log on both sides. Oops, got my natural log there. This equals that. I'm going to bring my exponents out front. 1 plus x, natural log 0.3. 2 minus x, natural log 1.7. I'm going to distribute. So this is 1 times natural log 0.3 plus x times natural log 0.3 equals 2 times natural log 1.7 minus x natural log 1.7. All right, I want my x's on. I'm going to bring my x's to the left. Anything without an x, I'm going to take it to the right. So I'm going to leave x natural log 0.3 where it is. I'm going to take this minus x natural log 1.7 and bring it to the left, so it'll become a plus x natural log 1.7. I'm going to leave my 2 natural log 1.7 where it is, and I'm going to take this natural log 0.3 and move it over to the right side, minus natural log 0.3. We'll factor out an x. X times, can y'all see this okay? I guess so. Natural log 0.3 plus natural log 1.7 equals 2 natural log 1.7 minus natural log 0.3. And finally, I'm going to divide both sides by this whole thing here. And I'm going to get 2 natural log 1.7 minus natural log 0.3 divided by natural log 0.3 plus natural log 1.7. So let's see what that is. Remember, math, left arrow. If you have a calculator, math left arrow. I'm going to make a fraction here. So 2 ln 1.7, close my parentheses, minus ln 0.3, close my parentheses. And now on the bottom of the fraction, natural log 0.3, close my parentheses, plus natural log 1.7, close my parentheses. And my answer is negative 3.364. Negative 3.364. And then I could check that pretty easily. Okay? Log base 3 of x plus 4 is equal to 2. Okay. I'm going to exponentiate this. I'm going to say 3 to the log base 3 of absolute value of x plus 4 equals 3 squared. So absolute value of x plus 4 is equal to 9. What this is telling me is whatever's inside the parentheses, inside the absolute value is 9 away from 0. So either x plus 4 equals 9 or x plus 4 equals negative 9. If I subtract 4 here, I get 5. If I subtract 4 here, I get negative 13. Because of the absolute value, either one of these is a good answer, 5 or negative 13. Either one's fine. All right, so when I have e to the 2x power, that's the same as e to the x squared. So I have e to the x squared minus 5 e to the x plus 4 equals 0. So this is a quadratic, and I can factor this, but instead of having x times x for the first terms to be x squared, I'm going to have e to the x times e to the x to equal e to the 2x. All right, remember when I multiply these together, I add the exponents, and x plus x gives me the 2x. So I want two numbers that multiply to give me 4 that add to give me negative 5, and that would be negative 4 and negative 1. So, splitting this apart, I've got e to the x minus 4 equals 0. So e to the x equals 4. I'm going to do natural log on both sides. So left side just becomes x. X equals natural log 4. And we can put that in the calculator. Natural log 4 is 1.386. Okay? On the other one, e to the x minus 1 equals 0. So e to the x equals 1, and I do natural log on both sides. And x equals natural log 1. Natural log 1 is 0 because e to the 0 power equals 1. And if you're not sure about that, we do natural log 1, and you'll see that it's 0. And that's actually exactly 0. Okay? Number 6, I've got a common factor of e to the x. E to the x times x squared minus 3 equals 0. So either e to the x equals 0 or x squared minus 3 equals 0. Well, if you think about the graph of e to the x power, remember that all these exponentials, they hug the x-axis and then they shoot up, right? But it's never equal to 0. It's impossible. E to the x cannot equal 0, so I don't get any solutions from that part. On this side, I've got x squared is equal to 3, so x is equal to the positive or negative square root of 3, and that's it. Okay, my answer is positive or negative square root of 3. All right? Okay. Could y'all see that? Sorry about that. Okay, there we go. That's it for today. We're closing in on the end of all this stuff. Test will be no earlier than Friday next week. I might push it back to the following Monday. We'll see. All right, talk to you later. Have a good weekend. Bye-bye.